Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to solve systems of linear equations using the elimination method. Other than solving by graphing, there are two other ways to solve linear systems algebraically: by substitution and by elimination. And today we're going to focus on the elimination method, which in a nutshell is basically the concept where you're going to eliminate or cancel or get rid of one of the variables in the system and then solve for the remaining variable. It's quite easy. And the first thing you always want to make sure you have perfect is that the given equations are written in standard form. That's ax plus by equals c form. Be sure to line up the equations same variable to same variable. Then once that's done, you're going to add the equations together, making sure that one of the variables is eliminated. You want to get rid of it. And then you're going to solve for the value of the missing variable. For example, the question we have here, if we add both of these equations together in this system, you very easily note that the x's will cancel, and I have 6y is equal to negative 36. Going to go ahead and divide 6 to both sides, and y equals negative 6. Now that you know that y equals negative 6, you're going to go ahead and plug that value back into either of the original equations that was given to you. For my purposes, I'm going to go ahead and choose to plug it into the first equation. So for x, 8 times negative 6 is minus 48 equals negative 24. Add the 48 to both sides. And 4x equals 24. Divide by 4. And x equals 6. So my solution is 6, negative 6. And I'm not going to check the solution for all of these in this video, but I will remind you that checking is very important and useful because it makes sure you didn't make any errors. So for example, let's check the first equation here. 4 times 6 is 24. 8 times negative 6 is negative 48. When added together, does equal negative 24. Works for the first one. Negative 4 times 6 is negative 24. Negative 2 times negative 6 is positive 12, which equals negative 12. And they both work. So 6, negative 6 is the solution. All right, let's go. Sometimes you will have equations that do not eliminate easily. In these cases, you need to line up the equations in standard form. Once again, ax plus by equals c form, and create an equivalent system by multiplying each side of one or both of the equations in the system by the same non-zero number. What am I talking about here? For this particular case, me personally, I want to go ahead and eliminate the x's. So in order to do that, I have to make the coefficients opposite. So I'm going to multiply a negative 4 to this top equation and a positive 7 to the second bottom equation. Then I'm going to distribute these values to each value appropriately in each equation. So I've got 28x plus 32y equals negative 36. Plus negative 28x plus 63y equals negative 154. As you can see, the x's cancel. Got 95y equals negative 190 divided by 95. Y equals negative 2. Please remember that now you have to plug that value into either of the original equations to solve for the other variable. So I'm going to choose the bottom equation here. So I've got negative 4x, negative 2 times 9 is negative 18, equals negative 22. add the negative 18 to both sides, or add the positive 18 to both sides. Negative 4x equals negative 4. Divide negative 4 to both sides, and x equals 1. So my solution is 1 comma negative 2. And please remember to check that solution on your own. Okay, let's continue. For 3a here, me personally, I'm going to change things up and I'm going to go ahead and eliminate the y's. So all I got to do here is multiply the bottom equation by 3. So then I have negative 4x minus 15y equals negative 17. And I've got negative 3x plus 15y equals negative 39. My y's cancel and I have negative 7x equals negative 56 divided by negative 7, x equals 8. Now that I have x equals 8, please remember that I'm going to have to plug that x value into either of the original equations that was given to me. Me personally, I'm going to choose to plug it into the top equation, first equation here. So I've got negative 4 times 8 is negative 32 minus 15y equals negative 17. Add 32 to both sides. Negative 15y equals 15. Divided by negative 15. Y equals negative 1. So my solution is 8, negative 1. Awesome. Let's go. Okay, next. In this particular case, both of the equations are not in standard form. So the first thing you have to do is manipulate one or both of the equations to make sure they're in standard form. So I'm going to add 14y to both sides. And then I'm going to have negative 6x minus 7y equals negative 10 plus my 8x plus 14y equals 4. I'm going to go ahead and choose to eliminate the y's. Be the easiest for me. So I'm going to multiply up here by a positive 2. So this is going to then give me negative 12x minus 14y equals negative 20 plus 8x plus 14y equals 4. Got then negative 4x equals, the y's cancel, negative 16, divide by negative 4, x equals 4. Now that x equals 4, please remember that you must plug in that x into either of the original equations. And I'm going to go ahead and choose to solve for y by plugging it into the second equation here. 8 times 4 is 32. That equals negative 14y plus 4. Subtract 4 to both sides. 28 equals negative 14y divided by negative 14. Y equals negative 2. So my solution for 3b is 4 comma negative 2. Let's go. Last mechanical question. Let's go ahead and solve this by elimination. And here you choose what you want to solve for. Me personally, I'm going to go ahead and eliminate, let's say, the x's. And to do that, I'm going to go ahead and multiply the first equation by a positive 5 and the second equation by a positive 2. So now I'm going to remember distribute. And that's going to give me 10x plus 40y equals 30 plus negative 10x minus 40y equals negative 30. Now here we have a special situation where everything cancels. When you have the variables cancel and you are left with a true statement, that means that this is a consistent dependent system. That means it's the same line. So that means you have infinitely many solutions or all real numbers. All right, so I hope the mechanics are down pat. Now let's get to these word problems. Carlos and Juan attend a baseball game with their kids. They get to the game early to watch batting practice and have a dinner. Juan says that he'll buy dinner. He purchases 7 hot dogs and 5 sodas for $38.25. After the 6th inning, everyone is hungry again. So Carlos purchases 5 hot dogs and 4 sodas for $28.50. Find the price of each hot dog, sorry about that, and each soda. Well, first things first, let's label our unknowns. Me personally, I'm going to go ahead and say that X is the cost of the hot dogs and Y is the soda cost. So if that's the case, I know that Juan paid $38.25 for 7X hot dogs and 5 Y sodas. And then Juan paid $28.50 for 5X hot dogs and 4 Y sodas. Okay, let's give us some space here. Let me move this over here. Let me move this over here. And first things first, we got to decide who we want to eliminate. Me personally, I'm going to eliminate the x's. So I'm going to multiply the first equation by a -5 and their second equation by a +7. Use your trusty calculator. 38.25 times my -5 gives me -191.25. That equals -35x minus 25y. 28.5 times 7 is +199.5. And that's going to equal 35x plus 28y. -191.25 plus the 199.5 equals 390.75, which equals the x's cancel, 3y. When I divide that by 3, sorry here, guys. Made a little error here. It's not 390. 199.5 minus 191.25 equals 825. I'm actually glad that I made this mistake, to be honest with you, because we all make mistakes. And I noticed that that was way too large. I knew I had done something wrong. So I just looked at my equation again, looked at my calculations, and realized that I just made a simple error. So now let's fix that. And now let's go ahead and do this properly. And y is 275. 275 for every soda. Sorry about that error, but at the same time, that's going to happen in real life. So it's a good lesson. Now that we have y, we got to plug it into the original equation to either one. You can plug it into the top or the bottom one. I'm going to go ahead and choose to plug that y into the top equation. So I've got 38.25 equals 7x, and 5 times 2.75 equals 1375. Subtract that from both sides. And then solve for x by dividing by 7. And is $3.50 for every hot dog. Bam! And last but not least, at Burgers Inc., 5 cheeseburgers and 3 medium shakes cost $15.50. The cost of 3 cheeseburgers and 2 medium shakes is $9.75. Find the cost of each cheeseburger and medium shake. First things first, let's label. So I'm going to call X the cost of each cheeseburger. And I'm going to call Y the cost of each medium shake. And I know that for $15.50, I purchased 3 X cheeseburgers and 2 Y shakes. And for $9.75, I purchased, I'm sorry, I read it incorrectly. For $15.50, it's 5 cheeseburgers, pay attention, Moro, and 3 shakes. And for $9.75, you paid for 3 cheeseburgers X and 2 Y shakes. I'm going to go ahead and decide to eliminate the Y's. So I'm going to multiply this first equation by a 2 and this second equation by a -3. So let's go ahead and distribute that 2 first. And that's going to be 31 equals 10x plus 6y. And then I got that 975 times that -3, negative 29.25 equals negative 9x minus 6y. So 31 minus the 29.25 was $1.75, which is the value of X. So the cheeseburgers are $1.75 for each cheeseburger. Now I plug in that X value into either of the original equations I started with. So this is pretty simple. I'm going to go ahead and choose to plug it into the second equation. So I've got 9.75 equals 3 times 1.75, which is 525, plus my 2y. Subtract my 525. You got 450 equals 2y, divide by 2, and there you have it. The shakes are $2.25. So there's elimination. Hope you enjoyed it. Hope you learned a lot. Thank you. Come back anytime. Have a great day. Bye-bye now.